Okay, so I'm doing problem number 4 in section 1.1. And the question reads, a bicyclist is riding on a path modeled by the function f of x equals 0.08x, where x and f of x are measured in miles. Find the rate of change of elevation when x equals 2. And the instructions for the entire section read, decide whether the problem can be solved using pre-calculus or whether calculus is required. If the problem can be solved using pre-calculus, solve it. If the problem seems to require calculus, explain your reasoning and use a graphical and numerical approach to estimate the solution. So I decided that given the fact that we can see that from the graph itself that the slope was constant, as well as the fact that the equation itself is in the y equals mx plus b form, that the slope is constant, that we can use pre-calculus to solve this problem. So given the fact that the slope is constant, we know that at all points on the graph, the rate of change for the elevation over the change in horizontal distance should be the same. So on the graph, I've labeled the value of f of x at 2, which is 0.16, and at 6, because that was the one in the textbook, which is at 0.48. So even though we already know that given the y equals mx plus b form, 0.08 should be our slope, in order to confirm, I took the rise over run formula, the change in y over change in x, and I used the values at 0, 0, and 2, 0.16, and I evaluated and confirmed the slope to be 0.08. And there are units on this graph, which are miles vertical and miles horizontal, so the slope would be 0.08 miles vertical over miles horizontal. And we know that this will be the rate of change of elevation for all points, given that this slope is constant throughout the entire graph.